All right, let's talk a little bit about the history of dynamics, and we are now in chapter 6, taking a little side trip. So we need to look at the Greeks. We need to talk about some historical figures and what they discovered that led us to our current understanding of physics. Back then, they really considered something called natural motion, and they thought it was caused by some internal quality of an object that made it seek a certain preferred position without any application of force. So natural motion could be that it was at rest, or natural motion could be that it was moving, say a bird flying, that was a natural motion. An unnatural motion was anything else, anything that altered from its normal state of being. Unnatural motion was thought to require applied force to be sustained, and so we're going to look at how that has transferred into our current knowledge. Natural motions were divided into two categories. They had terrestrial, meaning near the earth, or celestial, in the heavens. Then Aristotle started talking that an object's heaviness determined how vigorously it sought its natural place. So he really was kind of getting the idea of mass, even though they didn't have that word just yet. Galileo came along and began collecting facts and establishing his description of motion, and we now call this kinematics. Galileo then started developing a workable theory of dynamics, and his experiments showed that the rate at which an object falls is not proportional to its size or mass. In other words, gravity has the same effect on every object. Astronauts later verified his theory on the moon. We now understand the concept of gravity is different. The measurement 9.8 meters per second squared is different on Earth than the moon. The moon's gravity is much less than the Earth because it's proportionate to its size. Ad hoc is a term that indicates a hypothesis that was based on conjecture rather than observation. A lot of times this is an attempt to explain a natural phenomenon, and it's just something that instead of observing it, it's just a natural phenomenon. You noticed it, and so you try to explain that through your hypothesis. All right, Galileo's experiments of unnatural motion indicated that the natural state of motion of an object could include moving as well as resting. And inertia really is the tendency of an object to either remain in motion or remain at rest unless an outside force acts upon it. So Galileo was very early on in understanding this idea of inertia. His principle of inertia states that an object will continue in its original state of motion unless some outside agent acts on it. A moving object does not require a continuous push to maintain a constant velocity. If an object is in motion, it will stay in motion unless some outside force acts on it and stops it. Most of the time, if you roll a ball or you roll a Hot Wheels car down a track or something like that, usually you end up with friction as that outside force that will eventually slow it down. A push causes a change in an object's motion, and that's when we start looking at forces. Okay, Newton came along and he built on the work of others. He studied gravitation. His Principia, his primary or first principle of gravity, we know the historical story where he had an apple fall on his head and he had to consider what was causing that. Only in recent decades have scientists been able to discover any exceptions to his work, and mostly that is due to our advancement in technology and having better tools at our disposal.